This week we do experiment number 4, so I suggest you should finish this lab before you start doing exam number 1. So you're gonna learn more materials about gas law after you complete this, which is there's a lot of questions related to gas law on your experiment number 1, on your exam number 1. So log into your lab archives and load your lab notebooks in a new window. So make sure you read the introduction first. Introduction. So this lab we're gonna analyze the ideal gas law using vinegar and baking soda to reduce carbon dioxide. So you can get vinegar and baking soda from CVS or from grocery store, and the reaction between vinegar and baking soda is gonna produce carbon dioxide, which is a gas. And you also do some experiment um, related to this ideal gas law. So here is your ideal gas law, PV equal nRT. So P is pressure, V is volume, equal N, which is number of particles or number of moles, R is a gas constant, and T is temperature. This ideal gas law is only applied to gas molecules. So if you have solid or liquid, this ideal gas law cannot be applied. And in this lab, we're gonna find out the relationship of all of these quantities, how it's gonna relate it, how it's gonna be affect each other. So their relationship, it should be proportional or inverse proportional. You're gonna find out that in experiment. So the reaction between the vinegar and the baking soda, which is NaHCO3, is gonna produce carbon dioxide gas. We're gonna examine the behavior of carbon dioxide gas to make some assumptions based on your gas law experiment. So for this lab, last week we have been told to prepare 3 bottled waters. One of the full water bottle we're gonna put in the freezer to make the solid, which is the ice. And the second bottle we're gonna leave it outside in the room temperature, which is the liquid. And the third bottles, we should have it empty, which is gas stays. So it should be 3 bottles, okay? And based on all of this description, you're gonna answer all of these questions. So all of them should be yes and no questions. So at the end, you're gonna make the summary table and fill out yes, no, or yes, no in this table. So for example, you have done some compressions. Most of solids, we cannot compress it. We cannot squeeze it, so it's gonna be no for solids. Same thing with liquid. We cannot squeeze the liquid, so no compression for liquid, but for the gas molecules, we can squeeze the bottles. So gas molecule can be compressed. And this video is show the gas flow test. So you're gonna see if the gas molecule can flow. So he mixed baking soda with vinegar and it's gonna produce carbon dioxide gas. And he tested, is it the carbon dioxide gas, which is a gas, is it can flow to extinguish the flame on the candle. So if it happen, then gas molecule should flow. So same thing with liquid. If you can pour the liquid, which is liquid can be a flow also. So for the second part B, we're gonna find out the relationship between temperature and volumes. So you need some latex balloon and you measure the diameters of the balloons, then we're gonna calculate the circumference. So the equation to calculate the circumference from diameter is gonna be circumference equal 3.14, which is the pi number, multiplied with the diameter. So whatever your diameter is, multiply it by pi number, which is 3.14 to get the circumference. Then you're gonna measure 3 conditions: room temperature, freezer, and liquid nitrogen. So from top to bottom, temperature should be decreased. And you're gonna compare, is this the circumference it also decreased from top to bottoms? If it does, then the relationship between temperature and volume should be directly or proportional. So you're gonna complete right here. If the temperature drop, cooling, going down, and the circumference increase, and the relationship between temperature and volume should be inverse proportional. So based on your result table. So since we don't have liquid nitrogen at home, the video provided at the bottom here, it should show the demo of balloon and how the liquid nitrogen, which is very cold, very low temperature, affect the size of your balloon. And the number of particles and volumes. So number of particles, which is n's, and volume. So what is this relationship? So you may need a balance. If you don't have the balance, that's fine. You need a baking soda and vinegar. So you can approximately measure 3 amounts of baking soda, 2 grams or 1/4 teaspoon, 5 grams and 10 grams approximately. And you're gonna, so the more amount of baking soda have been added to vinegar, which is more number of particles, more number of gas particles, or higher number of N. And you're gonna see how it's gonna affect the volume. So how it's gonna affect the size of the balloon. Then you can make the result table. You can repeat A the second time, so you're gonna make the result in A2. Same thing with B and C2. So you don't have to make 2 times, but if you finish the first time, then you only need to fill out A1, B1, and C1. Then you're gonna see the relationship between the amount of baking soda, which is your number of moles, which is N, how it's gonna affect the diameters, which is the volume of your balloon. So if they are both increased, then it's gonna be directly proportional. If one increase, the other one decrease, then the relationship should be inverse proportional. So there are two conditions, and one should be applied only. And part D, we're gonna find out the relationship between temperature and pressure. So you don't have to do this experiment. There's video provided for you, but you also can make it, but it is optional. So watch these videos. The guys in this video prepare this experiment and they explain it very clearly. You're gonna be able to answer all of these questions related to this. And same thing, find out their relationship again. And the part E, find out number of particles. It should be no space between here, so it should be number of particles and pressure, so N and P. Watch these videos and then find out the relationship is inverse or not, or proportional. For the last part, which is the simulation of ideal gas law, so make sure you use the split screen. Okay, so click on ideals. Then lift the bicycle pump handle to let the gas molecule in. So this is your container, and this one is your thermometer to measure the temperature, and this one is to measure the pressure. Then this one, you're gonna use it to increase or decrease the temperature. You can add heat or you can cool it down. So let's add some gas molecules. So as you see, when we initially release some gas molecule into the container, the pressure starts to change and it can increase. So what is temperature? So temperature should reach 300. If you add another pump, second pump, which is mean the second amount of N or gas particle have been added to the container, and temperature stay the same and pressure is increased. So do all the particles have the same kinetic energy? So based on your observations, you see all gas molecule is moving in all directions. It only change the direction when it bump into the walls or when it interact to each other, and it's gonna change directions. So as you see, them moving in different speed, different velocity, which is all of them have different kinetic energies. So when we increase the heat, so we're gonna do this to increase the heat. So if you did this, then you're gonna see, you're gonna stop at any moment and then record the new temperature. So you can choose different molecules. So this way you can add another type of gas molecules. So now you have the gas molecules. As you can see, it's a little bit smaller than the blue one, and it's moving a little bit faster. So it has higher kinetic energies compared to the blue gas molecules. Okay, so that should be your answers. And so you're gonna read all of the instruction and apply it on your simulation, then fill out the answers. And you also can lower the temperature of gas. Um, you're gonna reset it. So this is the reset button. Reset it and hold the volume constant. Um, as it says right here, hold the volume constant and add some gas molecules. So let's add 2 pump. And lower temperature to 100K. So you're gonna lower temperature, which is we gonna cool it down. You don't have to be exactly 100, so you can start at 101. That should fine, or 99. So if you got 99, just put down 99K. A little bit tedious if you can make it exactly 100K. And then you're gonna record the pressure in this case. So any number should be fine between 3.6 to 4.3 or something. And then you're gonna increase the temperature by 110 each time. So let's increase the temperature another 100, which is 200K. So let's say it's 195, it should be okay. And now your pressure is also increased almost a double amount. So from 3 point something to 4 point something, now it's gonna increase to almost 8. So as you can see, the relationship between temperature and pressure, that how many times we increase the temperature, that also exactly the amount of pressure gonna be multiplied by. You're gonna do it 6 times, so until you reach 600. So basically, to add another row, just hit tab. Okay, remember we learned this. And then you're gonna fill out the 3 times. So from 100K, 200K, 300K up to 600K, which is 6 times totals. Then you should expect that as we increase the temperature by 6 times, pressure is also increased by that amount of times compared to originally set. Okay, and you should be answer of this question following. So this is pretty much about the gas laws. It's very straightforward, and make sure you know memorize the equation, Ardell's gas law equation, PV equal nRT. So if you have watched lecture video and prepare for your exam number 1, this Ardell's gas law, if you memorize it directly tell you the relationship between them. So for example, PV, they are on the same side of the equation, so they are gonna be inverse proportional, which is if I increase P, V is gonna be decreased. Same thing with N and T, which is number of moles and temperature. They are on the same side, same right side of your equation. So their relationship should be inverse proportionals, which is one increase, the other one have to be decreased. So the relationship between two quantities from both sides of the equation, for example, V and T, so they are from both sides of the equation. Their relationship is directly proportional, or they both increase or they both decrease. Okay, so same thing with P and N, or same thing with P and T. So any quantities, if they are from two sides of the equation of the ideal gas law equation, they should be directly proportional. Okay, if the two quantities on the same side of the equation, for example P and V, they are on the same side, on the left side of this equation, their relationship should be inverse proportional. So all of your experiment, it should prove this theory is correct. So this is a second double check. If you have made some result table or some conclusions, make sure you check from with your ideal gas law originally. Okay, so good luck everyone. So after you finish, make sure you take the lab quiz on Canvas. It was 20 points. The lab archive submission, it was 10 points. Okay, I'll see you again.